What's up, guys? Here we are with 2.2, linear relations and functions. Emphasis on the fun. Okay, a linear relation is a straight line graph. Okay, we're talking about straight line graphs. Non-linear means it's not a straight line graph. It's going to be curved, have some sort of curves in there, like parabolas or x to the third. Okay. So a linear equation is only going to have plus, minus, times, and divide. Division is in multiplying by a fraction. Okay, because one of our rules later on says no division by variables. Okay, well this is kind of multiplying by a fraction is what that division is. Like you're dividing by the number, x over 2, or x times a half, same thing. So it'd be the same as multiplying. Rules that you can't do, we can't multiply variables together. So no y equals x times w. In a 3-variable system like that, that's going to produce a curve. And no y equals x squared, because that's x times x. And we know that's not a straight line graph. That's going to produce a curve as well. And then rule number 2 is no variables on the bottom. When you have a variable on the bottom like that, we're going to get hyperbolas, and those are a lot of fun. We'll get to those later. So a linear function is a function that satisfies a linear equation. The most common one you probably know is y equals mx plus b, or if it's written in function notation, it could be f of x equals mx plus b, or g of x equals mx plus b. Lots of stuff like that. Alright, so just quick, right there, think about this a little bit. Using our rules that we just talked about, which of these 4 would be linear functions and which would not? And if it's not, why not? Half x plus 2. Alright, half x plus 2. So we're multiplying by a number, that's okay, and then we're adding a number, that's okay. And you probably recognize this as a linear graph from Algebra 1. The slope of a half and a y-intercept of 2. So you know this one's a line. We're good. That one is a linear function. Yes, linear. Okay. H of x equals z times w plus 1. So remember this h of x or f of x, it's kind of like your y equals. So we got 2 variables multiplied together here. That is a no-no. That's going to produce a curve of sorts. So no, this one's non-linear. What about 3 over x? Oh, 2 over x plus 1. This one's a no-go here as well. X is on the bottom. That's a no-no. Non-linear. Here's a tricky one. Think about it. 3 plus x, all divided by 2, minus 1. Are we breaking any rules? Nope, we are not. We got addition, we got subtraction. You're like, oh, we got division. Well, we're dividing by 2. That's the same as multiplying by a half. Really, we could change this to 3 halves plus x over 2 minus 1. You could change it to that and simplify and combine. And then it would be pretty close to that, this one up here. All right, another form of a line is the standard form. Instead of y equals mx plus b, which is slope-intercept form, we're going to talk about that again in just a second. But the standard form is ax plus by equals c, where a, b, and c are all integers. Think about what an integer is. Okay, positive and negative whole numbers and 0. Okay, with greatest common factor of 1. What does GCF, greatest common factor of 1, mean? All 3 of those numbers, A, B, C, you can't divide anything else out. So if you can reduce, reduce. Like this example here, 4x plus 8y equals 16. Currently, the GCF would be 4. 4 goes into all 3 of them, so I can divide everything by 4. And now I'm down to 1x plus 2y equals 4. So kind of reduce it if you can. Okay, it's good math grammar to keep that front one positive. Okay, or if it's nothing there, if it's a 0, it's a 0. But we don't want to lead it off with a negative. And A and B can not both both be 0 at the same time. Because if this is 0 and this is 0, and this is a number, that's not true. And if this is 0, 0, and this is 0, well, what's the point, right? There's nothing there of anything. Okay, so how can I change this into slope-intercept form? All right, so this should be a two-step process here from Algebra 1. Because initially this might not be the most friendly thing to graph for you, although we will talk about a way that makes it a little more friendly. We also want to identify, just practice identifying ax plus by equals c. A is 3, b is 2, c is 12. Why did I say 3? C is 12. Okay, so step 1, we need to get rid of this x, minus 3x. So we got 2y equals negative 3x plus 9. And then divide by 2. Y equals negative 3 halves x plus 4 halves, or plus 4.5. And now we're in slope-intercept form, which you might be a little more familiar with. Okay? Going slope-intercept form to standard form. Flip it back. Okay, remember, standard form is ax plus by equals c. So we want x and y on the same side. So I got to add this over, plus 3 halves x. So I got 3 halves x plus y equals 6. Okay, they're all over there together. And what else do we need? A, B, and C are integers. A, B, and C need to be integers. Do we have integers? 1.5, that's not an integer. So we gotta, what can we multiply everything by so that we'd have positive and negative whole numbers across everything there? 3 halves. We could multiply everything by 2. Alright, so that's going to make 3 halves times 2 is just going to be 3x. 2 times y is 2y. And this is a real easy common mistake, guys. It's so easy, but it's also really easy to make. Because you're like, oh, I picked 2 to get rid of this, so this is a 3. And then we forget about the y, and we get in a rush to do 6 times 2 for 12. And we forget about the y. It's a real easy one to make, a real sneaky little mistake. Okay, make sure you're taking it to everything. All right. So there we are. Now we've changed that back into standard form. Okay. Here we have another one in standard form. Let's change it back to slope-intercept form. Y equals mx plus b form. But before we go, so I'm going to have you push pause here in just a second and try this on your own. I want you to identify A, B, and C, write those down over here, and then change this into y equals form, slope-intercept form. All right, go ahead and hit pause and try that on your own. All right, welcome back. Let's see how we did. Step 1, we're going to subtract the 2x over, so we have 12y equals negative 2x plus 21. Oh, I didn't put this in. A was 2, B was 12, C was 21. You guys are probably too young to know that joke. I don't even know if it's a joke, more of a meme. Okay, and let's divide by 12. Yucky yuck. Y equals negative 1/6 x, or negative x over 6, however you want to write it. I'm okay with whatever, guys. Okay, however you want to write that. 21/12 divided by 3, 7/4. Fun. There you go. All right. Okay, we're going to have you try it again here. Let's go convert to standard. So we're in slope-intercept, kind of. Not really. Close. But we're going to have you convert to standard. Okay? We want this to be an ax plus by equals c form. Ready, set, go. Okie dokes, welcome back. Let's see how we did. We want to have them all on the same side, all right? Just because, you probably didn't do this way, maybe you did, but just because I want to show you what happens, we're going to do it this way. I'm going to subtract the 8x over. 3 equals negative 8x plus 3/5 y. All right? Okay, I see the fraction. I know I got to get rid of that. So I'm going to multiply everything by 5. 15. Negative 40x plus 3y. And you're like, okay, ax plus by equals c. Well, I have c equals ax plus by, so let's just flip this, huh? Negative 40x plus 3y. I'm losing my voice. I've done so many videos today. Equals 15. Okay, and we're thinking we're good, right? We're done. Careful, careful. It's bad math grammar to lead off a standard form with a being negative. We want a to be greater than or equal to 0, aka positive. If there is an a, it's got to be positive. So, fix that. Real quick, easy fix. Multiply everything by negative 1. Positive 40x now. Negative 3y. Negative 15. Or minus 3y instead. Okay? You might be wondering why standard form is so important. It seems like all we're going to really do is switch it over to slope-intercept form if we want to graph it. Why do we even mess around with standard form? Okay, well, here is a really nice thing about standard form. It's actually really, really nice. It can be really, really nice to graph. Even nicer than slope-intercept form because your 2 points are so easy. Okay, look at this one here. 2x plus 5y equals 10. Okay, think about if I want to know what my x and y intercepts are. Think about what my x-intercept is. What is my x-intercept? Okay, that's where it crosses the x-axis. Where it crosses the x-axis is where my y value would be 0. So it's going to be something, comma, 0. So if I know that y is 0, put 0 in for y. What's 5 times y? Or 5 times 0? 0. So it's kind of like it's gone. Okay, this is what I call the cover-up method. Okay, you want to get your x-intercept, you cover up your y, because you're putting 0 in for it. That should make it be 0. Cover up your y's. 2x equals 10. X is 5. So my x-intercept would have been 5, comma 0. If I was graphing this, I can go to 5, comma 0, put my dot. Then my y-intercept is just the opposite thing, right? My y-intercept, where it crosses the y-axis, would be where my x is 0. So this is going to be 0, comma something. Same thing. If I want to know my y-intercept, I cover up the x. 2 times 0 is 0. Boop, it's gone. Okay? You cover up the x. 5y equals 10. Y is 2. Super easy. 0, comma 2. And then there's your 2 points, and you can draw your line. Okay? So it's really easy to get intercepts from that. Obviously, slope-intercept form is going to give you the y-intercept. This is really easy at both intercepts. And then that's your 2 points to draw your line. Okay, let's push pause and have you try this one on your own. Ready, set, go. All right, let's see how we did. X-intercept, y-intercept. So to get your x-intercept, we cover up the y's. 3x equals negative 12. X is negative 4. Negative 4, comma 0. To get my y-intercept, I cover up the x. Carefully you don't lose that negative. That negative kind of goes with the 4 there. Cover up the x. Negative 4y equals negative 12. Divide by negative 4. My y-intercept is going to be 0, comma, positive 3. All right, negative 12 divided by negative 4 is 0, comma, positive 3. All right, fun stuff, guys. That is section 2.2. Excellent work. Keep up the good work, guys. Keep working hard. We'll see you in class. Thanks a lot.